Hello and welcome back. In this tutorial, I will show you how to add a component into the component library. Let's get started. Make sure that there are no designs open. Under the Tools menu, select Component Library. This opens the Component Library dialog. You can enter transformers, capacitors, diodes, Zeners, inductors, etc. into the component library by selecting the appropriate tab. In this example, I will show you how to enter a core which is not present in the component library. Select the Transformers tab. Click the Add button. This opens up the dialog through which you will be asked to enter the required parameters. Let's give the name of the core as My Custom EF16. Clicking on this button allows you to assign which applications the core should be considered for. You can choose from several available options. When in doubt, select all the options. This will make the core available for all designs and all families. Click OK. Under the part number option, I'll enter the part number E16/8/5. Let's leave the manufacturer as generic for now. Now I need to enter the core parameters. Let's take a moment and understand what each of these 7 variables mean. What I have here is the front and top views of one half of a EE core. This is what two core halves look like when they are joined together. The cross-section of the center leg is what defines parameter AE. LE is the length of the magnetic path as shown here. AL is a parameter that is material dependent and can be obtained from the datasheet of the core. AW is the window area as shown here. The product of the window area AW and cross-sectional area AE define the power processing capability of the core. That leaves us with the other 3 parameters required in defining the core. This is a front view of a vertical bobbin. The parameter definitions remain the same for horizontal bobbins also. Parameter BW is the bobbin width. Parameter LT stands for length of a single turn and is literally the length of a turn going around the bare bobbin. This parameter is used in estimating the copper losses in the windings. The parameter BFW is the bobbin fit inside the window and is used by the software to determine whether or not the core halves will fit around the windings. Many times this parameter is not listed in datasheets and should be manually measured. A reasonable approximation of this variable is made by dividing the window area AW by the bobbin width BW. Allow for some loss of fit because of the thickness of the bobbin walls. With this explanation, let's enter the parameters relevant to our new custom EF16 core. The AE is 20.1 mm². The LE is 37.6 mm. The AL value from the datasheet is 980 nanohenry. The window area AW is 21.6 mm². Bobbin width BW is 9.4 mm. The length of a turn LT is 31 mm. And I am going to approximate the BFW as 2.25 mm. Now, every new core must have at least one bobbin associated with it. To add a bobbin, click this Add button. Enter a part number, manufacturer, and the orientation for this bobbin. For the part number, I am going to enter My EF16 bobbin. Since this bobbin has 4 primary side and 4 secondary side pins, I am going to associate the name with a P4 plus S4 notation to it. Enter the name of the bobbin manufacturer. I'll leave this as generic. The orientation can be either horizontal or vertical. This bobbin is horizontal, so I will leave this as horizontal. The parameter BWW is the same as the bobbin width and will be 9.4 mm in this case. The built-in margin on the left and right hand side is the distance from the winding area to the pins. In this case, this distance is greater than 3.2 mm on both sides, so I will leave this entry as is. I will enter the total number of primary and secondary side pins for this bobbin as 4 and 4. Click OK. It is important to point out here that every new core you enter into the component library must have a default bobbin associated with it. If it does not have a default bobbin associated with it, the software will not include that core during optimization. In this case, the default bobbin selected for this core was the previous placeholder. So I'm going to first remove it from the list, and then let's make sure that the bobbin I just entered has a check mark in the box next to it. This indicates that this will be the default bobbin for the core. And click OK again. Finally, click the Update Library button. I have added a new core into the database. Notice that this core has a user tag associated with it, as it is a custom core and it is included in the user library. Let's do a quick design to make sure that this core is in fact listed in the core list that the software uses. Let's go ahead and close this dialog. Let's do a quick tiny switch 4 design with universal input. I'll add a single output, say 5 volt at 1 amp. For this design, let's accept the defaults that the software suggests. It is important to understand that under the component sets you have all records as the selection. Click Finish. After optimization is over, let's open a design. Under the Transformer dialog, you should see the core you had manually added now show up. That concludes this tutorial. Good luck.